from this LUN to this LUN. And that is where storage vMotion come into picture. I know those who once you get into a company and start working, you do a lot of storage vMotion. I will tell you there are other reasons also for doing storage vMotions. But one good example for this is this. This is a old EMC storage and this is a Hitachi storage. Company is moving towards Hitachi. This can also happen when companies go through mergers. Companies go through data center consolidation. All these cases, this particular case can happen. So your ESX servers are configured the exact way, everything is fine. The storage is, this storage is presented to this server. Both the servers can see both the storage. That can be done even though it is from different vendors, it can be presented. So this is the condition. Now when I say storage vMotion is the process of moving a running virtual machine's storage, that means a running virtual machine's working directory and its disk files from one storage to another. So what storage vMotion does is this. When you do a storage vMotion, the VM will be running here. So when this VM is running, you know what is happening. It is using the processor of this server. It is using the memory of this server. This memory will be running this active state and everything. But what storage vMotion does is this. It moves the storage from here to here without having any problems to this VM. You getting what I'm saying? That is what is storage vMotion means. It moves that VM's storage from one storage to another storage without any service interruption. So you see that I move the storage from this LUN to another LUN. It can be different companies' LUN, it can be a different LUN. But the VM is continued to run. There is no service interruption. Absolutely no service interruption. And that can be achieved by using the technology called storage vMotion. VMware introduced this technology in 2005. From 2005 onwards, this was a big thing. It was a big blessing. In old days, before 2005, if I want to move this storage, this LUN or this storage of this VM from here to here, I have to power off this VM and then move this folder from here to here, because when I'm moving, and then power on the VM. You're getting what I'm saying? But that is no more required in today's world. You can do that when the VM is running. That is what a storage vMotion means. Now, one of the use case of storage vMotion is this. Now, all the VMs you migrated to a new storage, you can take this storage out and you can decommission that. Another reason for storage vMotion. For example, let us say, I will show you another reason. Okay, let us say this is a LUN. Let us say this is a 100 GB LUN. You have a VM here, you have another VM here, and you have another VM here. And now in this data store, let us say there is 10 GB free. Okay, listen to me very carefully. There are 3 VMs here. Let us say this is the first VM. There are 3 VMs there in this data store. Now there is 10 GB free space here. Now the owner of this particular server, let us say this particular server, is coming and telling, hey Deepu, I have a new database coming up, or I have new application to be installed on that server. I need some more space on my D drive or my C drive. Can you increase that drive from 40 GB to 60 GB? The drive is inside this one, right? We all know that there is a VMDK file here inside this server. This VMDK file is now 40 GB. They wanted to increase this to 60 GB. That means you need to add 20 more GB to that. Can you do that? Okay, Santosh is saying yes. How can you do that? Okay, if it is thin provisioned, it can be do that. Fine. But remember, okay, that's a good point. That's a good question. It is possible. I agree. But remember, thin provisioning is not widely used when it is in the server cases and all. Okay, thin provisioning is a good technology. It has its own drawbacks as well as it has its own advantages. Thin provisioning is more used in the workstation world when you're doing VMware VDI technologies. When we have hundreds and thousands of Windows XP and Windows 7, even if there is a storage problem comes, it's not going to make any critical problem. Maybe some of the workstations may stop working fine, but you may not want to take that risk by putting all your servers in provision. So thin provision is normal, is not widely used. It can be used when there is a situation like this. Yes, you can. But Santosh, I understand your question. So I hope you understand what I mean. But let us say my company standard is that we don't use any thin provision. Or take it this way, that particular disk I am talking is already thick provision. If it is already thick provision, you cannot make it to thin provision. In that case, is it possible? Let us forget thin provisioning for a minute. Can you increase the size to 20 GB more? There is only 10 GB free space. You cannot. So what can you do? What can you do to do it? There is another LUN here. There is another LUN in this environment, which is 100 GB free space. There is another LUN here, but that is another LUN. I can create a new disk. If they want an E drive, I can create a new E drive here and do that. But that is not the thing. He's asking to increase the existing drive. In that case, you can use storage vMotion. You can move this VM disk from here to this LUN to the whole thing. You can move when the VM is running. See, the end of the day, the goal is how you can do these kind of day-to-day activities, or these kind of expansions and all those things without disturbing the environment. Without disturbing the environment, I can always shut down the server and move it. That's fine. But with the VM running, I can move the storage from here to here, and I can expand that drive by doing storage vMotion. So that is another requirement, another case you can do that. So that is what storage vMotion means. Are you getting what I'm saying? So storage vMotion can be used in many cases. So we use a lot of storage vMotion. I use a lot of storage vMotion. Another case, thin provisioning, I will give you another example. Let us say I have a LUN, and in this LUN, there is, let's say there are hundreds of VMs here, maybe 20, 50 VMs are here. They are all thin provisioned, and the LUN is pretty much full. Now I got an alarm saying that, Deepu, be careful, the LUN is now pretty much full. It is almost showing red. That red means the LUN is 95% full. And all these VMs are thin provisioned. All these VMs are thin provisioned. If they are all going to use it, I'm going to run out of space. You know that you have 150% over provision. So if they all grow, it is going to be a problem. How do you address this issue? Two things you can do. One is you can increase the size of the LUN, which in my company we don't do. We have a standard size for every LUN. We use 1 terabyte size for every LUN. Just for the sake of an alarm, I'm not going to expand my LUN to 1.5 terabyte. No. I mean, I have to talk to my storage guys. They have to add more disks and all. That is not good. So the best option in that case for me is what? I will ask my storage guy, hey, you know what, Steve, give me a new LUN, another 1 terabyte LUN. And now I will do is, I will just storage vMotion some of the VMs here. Now I storage vMotion some of the VMs from here. Now my space in this one is reduced. It will become normal now, green. Now this is also green. You understand? That's the way you can do. So we do a lot of storage vMotions in my company to meet these kind of needs. So storage vMotion is not just used for LUN migrations and all. Storage vMotion is used widely for managing the disk capacities in our requirements. So it is something that you do very, very often in a busy environment. So let us try to do a storage vMotion here quickly, and then we have to move forward. So to do that storage vMotion, this is what I'm going to do. I wanted to pick a server that is in central storage. Okay, look here. This VM CentOS 6, it's on an iSCSI storage. It's a shared storage. So this server, I'm going to look at it and see what is there in this server. So I'm looking at the storage. Okay, this server has that iSCSI. It also has this iSCSI storage. Let me see what are the free spaces here. Okay, unfortunately that has only 3 GB there, but I can see there is a 56 GB free space on this NFS data store. You see that? So it is another shared storage. So what I'm going to do is, let us say my goal is to get rid of this storage. We are going to decommission this storage. This is probably from an old CX3 array from EMC. So now the storage guy came and said, Deepu, we have to clean this array because we are decommissioning this. We have some new storage, the NFS storage, or some iSCSI storage, or some fiber channel. But right now he said, Deepu, there is some storage. Can you free up this VM? This VM is on that storage, but I need to take this storage out. You cannot go to Gene and say, hey, Gene, I need to shut down this server and move the files because the storage team wants to take this LAN out. You cannot do that because that is a business outage. But I don't need to tell anybody. I don't even have to tell anybody. I can do it like this. Right click, migrate. This time I'm not doing change host. Change host is called the vMotion. Change data store is called storage vMotion. There is no such word called vMotion and storage vMotion. You don't see that in any VMware thing. It's a technology behind it. So changing host means, you're not touching the storage. You are moving the memory state. That is vMotion. When you just move the data store, that is called storage vMotion. Now if you do this, I'm going to the NFS data store, next, and finish. So now you can see that it is relocating the VM. You can see that this will change to NFS now, but you can see that the VM will continue to run on that server. There is no service interruption. That is called storage vMotion. Okay? Any questions for anybody on that? I'm moving forward. I have to get on to clustering now. Is this clear? What did you understand what that means? No response. Fine. I think they understand. So now I'm going to the clustering. You can watch this process here. I'm not going to wait for that to complete. Let us see what happens. So I'm going to get on to the clustering part. Okay. So this will happen in the back end. You know what it is. So clustering in VMware. So how many of you are familiar with some sort of clustering? So I need some interaction here. I need somebody to answer it. Who all are familiar with clustering? Any type of clustering. There are many technologies, Veritas clusters, Unix clusters, Solaris clusters, Microsoft clusters, and application clusters. Clustering itself, there are different type of clusters, which is called as NLB clusters. Network load balancer. That's also clusters. NLB clusters are there. These are all Microsoft terminologies. I think only Sri will have an idea, and I know Fanny is aware of it. Fanny is familiar with it, but Fanny sent me an email. He's in the class, but he's recording it, but he's busy with some outage. So he's not able to answer. So I think anybody else? Satya, you have any idea about clustering? All right. So guys, this is very important. Okay, I'm just trying to explain. Those if you are looking for and okay, let me on the wrong column. You can look here. Okay, so vMotion is still. So Microsoft clustering, Microsoft clustering is very popular, and you will definitely come across. I know my sound will break because I'm going to internet. Can you hear me now? Okay. If you go to this, you have to search in Google. I'm just trying to show you something about Microsoft clustering. So Microsoft clustering, probably this is a good place to start. You have to read about it, because when you go for interviews, even for VMware classes, they will ask you about Microsoft clustering, because many companies use Microsoft clustering a lot for their critical servers. So this is Microsoft clustering. There are many features. There are different type of technologies, how this clustering is done. So there is basically two type of clustering. Let me show you. I think it is mentioned somewhere here. So basically, there are three types of clustering. One is called as network load balancing, component load balancing, and then cluster service. So these are three types of clustering you can create. So I'm not going to get into that. I don't think you need to spend time to understand these two components. But what you need to understand is the cluster service, Microsoft cluster service. How Microsoft cluster service is happening. That is called as MSCS cluster, Microsoft cluster service. How that is done. Because I cannot spend time to teach you that, but that is very, very important. But if you read about it and you come back and ask me a question, hey Deepu, what is that quorum means? What is a resource group means? Things like that I can definitely answer. I'm more than happy to help you with. These are called different resource groups. You can create resource groups, and this is how you do it. And again, this is not just one document. Microsoft has many documents, and there are, if you go to internet, you can see that there are many other documents that are available for cluster service. Okay. Coming to Microsoft Windows 2008, Microsoft has improved their clustering technologies. I've been working on clustering probably from 97 onwards. I'm working on clustering. Windows NT time period onwards there was clustering, but when Windows 2000 came, that is when real clusters started coming up. Windows 2000 clusters were very powerful, very popular. Then it becomes 2003, nothing much changed. But when they moved to Windows 2008, Microsoft changed their clustering technology a little bit. There are many options now. It is called as failover clusters now. So the underlying technology has changed a little bit, but again, it is very similar. If you know, that's why I say you start understanding your clustering concept from 2003 clustering and then move to 2008. Even today, many companies are using 2003 clusters. Even in our office, we have many 2003 clusters, but all new clusters are 2008. In a cluster, so what is a cluster? Cluster is nothing but a group of servers together that can provide high availability service. It is basically for high availability. In our office, we have a 8-node SQL Server cluster. We have a 8-node file cluster. These are all Microsoft clusters I'm saying. So I have done from root to end of these type of large clusters by myself. But now I don't do that, but I used to configure Merrill Lynch major financial application clusters, major file servers, and things like that. I have some documents and all. I could possibly show you how complicated some of our clusters are. These are clusters with hundreds of LUNs and things like that. Anyway, we can talk about it if you are interested in that topic as a separate thing. Okay. So coming to Microsoft Windows 2008, they have something called as failover clustering. That is definitely an interesting thing. So this document probably is a good thing to start. Maybe I would strongly recommend you to read these documents. Okay. No, this is not correct. This is for virtual machine. That's not the one you want. This is the one. See, that's a blog actually. This is clearly explaining. This will tell you how to create cluster. This is the steps. Every one step by step is explaining. But you need to have Windows servers and things like that to links like that to do that. But again, try to understand at least clustering. So this is Microsoft clustering. See, this is a pretty good document. Whoever it is, I've shown you that. That's a pretty good document that will give you a good idea. Yes, every page, every screenshot he has put. So look at that. This is pretty much he has explained what it is. So try to get that basic understanding of what Microsoft clustering is and then read about it. So it's very important to know about Microsoft clustering because it is expected that you should know Microsoft clustering when you go for a job. Because if I am taking you as a VMware administrator, don't think that VMware administrator only do VMware thing, because all your guest operating systems are Windows or Linux, so you expect you do some operating system level task also, maybe more, and that is where they expect you to be aware of clustering and all. For example, let us say if I take Santosh to my team today as a VMware administrator, now that you are part of my team, and when let's say now next week Santosh is on call, so Santosh is going to do the on-call rotation. When you are on call, you are responsible for probably all my servers, at least in a first level. You may not need to troubleshoot it, but when it's a problem comes, when somebody say, hey, but this file share is not accessing, or a SQL DBA call and say, hey, this database is not accessible, I want you to at least get into that cluster, look at what is happening on the cluster, understand that problem, and then call my cluster expert and say, oh, John, there is a problem with this cluster, it's failed over or it is hanging or something. I don't want you to troubleshoot it, that's fine. But at least I want you to understand what that problem is and explain it. So that is where that key thing is important, okay? Anyway, Microsoft clustering is different, same way Veritas clusters are there. There are, in Solaris and Linux world, you can create clusters. Every operating system has their own technology. I'm not familiar with that. We do have large Oracle clusters, Solaris clusters in my office, but I'm not very familiar with it. All our Oracle servers are running in Solaris clusters, so I'm not very familiar with that. But anyway, that's it. It's also important to understand what is NLB, okay? Network load balancing. So that is also an important technology. Microsoft has their own NLB, but nowadays people use third-party hardware-based load balancing. One of the very famous load balancers that are used for NLB is called as F5 load balancers. CSS is another. NetScaler is another. These are all other hardware-based load balancers. So please try to understand those things. Radware, yeah. So there are many, but I would say F5 will be one of the best. So if you can put, if you can read about F5, understand what is F5, get familiarized with some of the screenshots of how F5 look like, how to operate, how to control. It's all web-based tools. You can put that in your resume. That will be a big plus, believe me, because if you are working in my environment, it is very important for you to have a good understanding about F5. Taking servers out of an F5 cluster for troubleshooting and things like that. So I'm not going to get into it. So NLB clusters are totally different from other clusters, but it is another way of balancing the clusters. In a quick way, I will just put it, not to confuse, I just put it in a, I don't want to run away because My mind is not allowing. So let's say these are all web servers, not VMs or anything. Okay, maybe VMs. Let us say this is how Bank of America's website is running. bankofamerica.com is running on all these servers, because just by running bankofamerica.com in one server is not possible. Because there are millions of people connecting to the site. So they wanted to share that load across every server. So every server is running bankofamerica.com, which will be talking to a centralized database. That's all in the backend. This may be the database. All these servers are talking to the backend database. That's all fine, but these are called front-end servers. Or this is what Bank of America website is running. The application and the databases are here. There are many layers, DMCs and external DMC, internal DMCs and all. I'm not going to get into that, but this is how it is. So these are not configured as Microsoft clusters. When it comes to this type of environments, they don't use Microsoft clusters. What they do is they can use a load balancer here, which is actually a physical device, which is basically a very powerful computer, which is running a proprietary operating system with proprietary application in that. It is actually from a company called Big IP. Big IP's product is called as F5. F5 load balancer. There are different varieties of F5s are there, like GTMs are there, LTMs are there, different types. You don't need to get into those, but this is an F5 load balancer. Let us say this is F5. So this is a hardware device. So what happens with F5 is, let us say you have one user sitting here in London, one user is in Ohio, one user in California. All these people are in their house, they are typing bankofamerica.com. When they type bankofamerica.com, their request will come here. Okay, everybody is typing bankofamerica.com. That will come directly to the F5 first, not to the servers. It comes to the F5. Now F5 uses some kind of algorithms. It can use round robin, first in first. There are many algorithms out there. I'm not, again, that's not needed to explain here, but it uses some algorithm. So the first user came, F5, say, okay, this guy is good. So your request go here. The second guy came, he said, okay, you go here. The third guy he said, you go here. Everybody is getting thing, but this load balancer here is balancing the load. It does not send all the requests to one server. It will know who is having what load, and based on that, it will send the request to different servers in the cluster. This kind of a thing is called as a NLB cluster. Okay, this is like I'm talking from a 10,000 feet height. So just to give you understanding what is NLB cluster, this is what so the F5 do that load balancing. F5 has that intelligence built inside it to do these things. Okay. So try to read about F5, try to understand about F5. See, when I say these things, these are very, very important things for you to find a job and to sustain in a job. That's what I'm saying. It's not part of VMware, it is not part of my job to teach you that, but I'm just telling you, if you can read and understand these things, it will definitely help you with your job. Okay, now coming to Microsoft VMware clustering. So VMware clustering is totally different from all these things. Don't think that VMware cluster is like that. VMware clustering is a totally different concept. I don't think there is any way you can compare a VMware cluster with Microsoft clustering or any of the other sort. It is a totally different concept, and that's what we're going to look into. And I would say a VMware cluster is pretty much maybe the easiest cluster to work with also. It is very simple and easy to manage also. If you understand how it works and how it operates, I think it will be very easy to handle it. So let us go and create a cluster. I will explain this as we know, and that is the best way to understand it. So I'm going to start doing the things, and that time we will understand how to create a cluster. So right click on the data center. You can create a cluster only at a data center level. Who is the major player for cluster? There is nothing like no major player for a cluster. And Microsoft clustering is different than my VMware cluster. It's for two different purposes. So you cannot create a Microsoft cluster, replace a Microsoft cluster with a VMware cluster. It's two different techniques. It's all called as clustering. Clustering is a technology for high availability. Every company has their own way of doing high availability. That's it. So you right click on this new data center or whatever the data center, and you can see there is something called new cluster. So here is how you create a cluster. Give it a name for your cluster. Let us call it as NYC underscore cluster underscore 01. That's the name of the cluster. I'm showing you how to create a VMware cluster. So VMware, a cluster means a group of ESX servers together so that they can work as a single resource. So if you have 5 ESX servers, each with the 10 GB RAM and each with 2 processors, I can say that I have a cluster with 50 GB of memory and 10 processors. That means I have that much of resources to give, and that resources can be shared among any number of VMs. It doesn't matter whether one ESX server is running some VMs or anything. A cluster is a single pool of resources. That is what a cluster is. So when it comes to VMware clustering, there are many features. One of the 2 features is called as HA and DRS. We will dive into each of those features individually, and we will learn. That is what the major thing we need to understand about cluster. So I'm going to name it as my new cluster. I'm not going to enable these technologies now. Let us create a cluster first. I want to show you something. If I click on this HA, you can see that VMware HA grayed out, and you can see that there are many options coming out. If I click on DRS, you can see that DRS has come and then another features are coming. So you can see that many things are coming up on the left as you enable. We will do these things later. Let us create a simple cluster without these features. So I'm creating the cluster, click next, and here comes another feature called EVC mode. Anybody remember I mentioning about EVC? Do you know where at what point I mentioned the word EVC? Yeah, where is it? What does that mean? Anybody know? So I mentioned that, at that point I'll explain what is EVC means. This is a new feature, not very new. This was introduced probably around 3 years back. That is when EVC mode was implemented. By default it is disabled. You don't have to use EVC mode. You have to use EVC mode in certain cases. So I'm going to explain this problem. Before moving further, let me explain EVC mode. This will be an interview question for sure. Okay. So let us take a case here. Let us say we have a cluster here. I'm building a cluster. I have a ESX server here, and I have another ESX server here. 2 HP servers, and both are running, let us say, Nehalem processors. Or let's say I'm not putting Nehalem. Let's say I'm taking Pendrain processor. That's a processor model, okay? Family name. Okay, I have 2 Pendrain processors. This was in 2008 or 2009. I bought these 2 servers, and I have many VMs. I can do vMotions. Can I do vMotion between these 2? If they are same processor, we can, right? That's what the vMotion's requirement. Now, after 1.5 years, my cluster become very busy because I have many VMs. Now there is no capacity here. Now I have to buy a new server. I went to HP and said, hey, you know what? I need a new server. with the Pendrin processor, and they said, Deepu, there is no way, we only have Nehalem processors now. So you bought a Nehalem processor here. Can you do vMotion now? No. Okay. So let us take like this. I'm just throwing another picture here. Let us say this is a Pendrin processor, the whole processor, and the Pendrin processor is having these many features, this much features. On the right hand side, I have a Nehalem processor, which is having the complete features of Pendrin plus some new features. That is what Nehalem means. Now we have my Intel has already introduced a new processor called as Sandy Bridge processor. Sandy Bridge has the complete features of Pendrin plus the complete features of Nehalem plus some additional features. This is what a Sandy Bridge is. So Sandy Bridge look like this. Okay. This is what the three processors are. Pendrin is like this, Nehalem is like this, Sandy Bridge is like this. Now you cannot do vMotion between this, can you? You cannot do because they are all different families. So this change is happening very fast nowadays. Every 6 months Intel is introducing new processors, or every year Intel is introducing. But I don't want to build a new cluster. I want to build my cluster big, and I don't care about these new features. Probably, I can just get rid of it. But all I care is vMotion. That's my important thing. So by doing EVC mode is a technique that is part of VMware's clustering, wherein you can mask these new features. So let us say if I have a technology available wherein I can just mask these features. Now all these processes look same, correct? Yes or no? If I mask that thing, that means the VMs cannot see that thing. Okay, you are understanding? That is what EVC mode does. So when you do EVC mode, which requires VMware clustering, you can use this technology and mask the greater features so that you can now do vMotion. Now when you try to vMotion, it is possible because the VM is not seeing these new features. Or a VM that is running on this server will not see these features. The VM is running here with only these features. What is the drawback of that? The drawback is that this VM does not get these new features. Okay, for me, that is not my important priority. My priority is to do vMotion. If I can do vMotion between here, I'm ready to do the EVC mode. So that is what is EVC means. You understand? So that means if you look here, by default, if all your servers are same thing. Again, understand one more thing. This is not possible for very old server. Let us say you have a Intel Xeon processor. You cannot do this EVC mode. EVC mode only works from certain models that I will show you now. If you have a very old server and you try to do EVC, it's not going to work. Okay. So disable EVC by default. There is no EVC mode. That means nothing is must. If I'm going to do, there are EVC mode for Intel and AMD servers. There is Intel and AMD host. Okay, Arvind is asking, once you reboot later, it gets all new CPU processor, right? I don't know what your question is. You're talking a different topic here. Once you reboot or not, if EVC mode is applied, whatever you do, you will not get it. If you don't reboot, if you reboot and there is no EVC mode, then it will get it. If there is EVC mode, it will mask. So you reboot or whatever you do, your VMs will never get that feature. So here is the thing, if you enable this EVC mode, and if you click on here, you can see that different company models. See Merome processors, that's the old generation. This is like the processor Intel released probably in 2005 time period, 2006. Then 2007 Penryn came. Then Nehalem came. Then Westmere came. Sandy Bridge came. You see that? So if you put this Penryn as the thing, you see here, read this carefully here. Applies the baseline feature of Intel Penryn. So that means if I take this, if I do this setting, Intel Penryn, that means whatever processors you have there, Nehalem or Westmere, all that are going to be masked. Your base level is Penryn. Okay? If I do Nehalem as my baseline, can you have Penryn processors in this? You cannot have, because if I say Nehalem is my base, then I cannot have Sandy Bridge. That is fine, but I cannot have this server here because all my VMs are going to see this feature, these two features. When it comes here, it will say you are different. So that is what this level is. Okay? So you have to understand. So if you put the Sandy Bridge, then everything is applied. And you can see that the new processor is called Ivy Bridge. You see that? That's Ivy Bridge. That's actually after Sandy Bridge. That is all there. So if you put Merome, then all these processors, you can see that future Intel processors, everything will be blocked. You will only get the features of Merome. That's the same thing for AMD also. When it comes to AMD, you can see that they have different things. They don't name it, but now they started naming it. It's called as AMD Generation 1, Generation 2, Generation 3, Generation 4. You see that? That's how actually AMD name their processors. They don't have this nice names, but they do put a name for their Generation 3. It's called as Greyhound. But typically, AMD processors are called as Generation 1, Generation 2, Generation 3. So that is what EVC mode means. So if you have an Intel processor and an AMD processor, do you think by doing EVC mode can help you to have a cluster with you can create a cluster with Intel processor servers and AMD processor servers. You can create a cluster, but you cannot do vMotions because they are two different families. And EVC cannot do anything there. EVC can be only applied to same set of servers, same family. Okay. So that is what EVC is. I'm not going to enable EVC, but if somebody asks you what is EVC, this is what EVC mode is. So click next. So we have EVC mode. We have disabled it. Then here it is calling store swap file in the same direction. What is a swap file? Where is a swap file? What is a swap file? Can anybody tell me what is a swap file? What is it used for? Okay, I need more answers. Okay, good. Everybody is giving. Okay, a little bit more answers. You know, Samrat, are you in the class? I never heard anybody. You never responding to my mails or talk, or you never take part in any of these conversation. Are you listening, or is there somebody else in your room? What is happening? Samrat, are you there? Okay. I will talk to you tomorrow. Okay. Memory. So here is the thing. So let us go through these answers. Okay. Sujan put memory used for clone. I don't know what that is. If I ask you what is swap file and if you say this answer, this is absolutely wrong. Raiden says it is the hard disk of the VM. Absolutely wrong. Aravind says snapshot. Another big wrong. Swap file used as memory. That one is having something is there. I think it is okay. It is swap file is used as memory. Okay, it is used as memory. I think that's a correct answer. I can give some marks, but you know I'm expecting more technical terms when it is. So Gene, you are right. You know what it is. But I am, you know, when I'm interviewing you as a 7-year experienced person, your resume says you have 7 years experience. I don't expect an answer from you like this. I expect a little bit more technical terms. You know, this is what I'm telling you the difference. You know, that's why you need to read. How many of you read about virtual memory? I told you many times, virtual memory. I told you page file. At least if any one of you use that 2 words, I would have given full marks. Santosh is saying extended RAM. Yeah, it is. It is an extended RAM, but you know, that's the thing. I expected the word called page file or virtual memory. Okay, guys, so you understand, I don't need to tell all these stories and waste my time, but I'm trying to make you guys to understand that. Okay, so this is the importance here. That is what makes a big difference. When you say these kind of answers, I know you are not really experienced person. That's the thing. Okay. Yeah. Did you eat? Okay. Okay, guys, sorry. So swap space is usually use 1.5 tensor, and that's all fine. Yeah, that's all correct actually. That's not a thumb rule. There is no need that it should be 1.5 times the RAM and all. That was probably an old Windows terminology. Now, today's world, most of the Windows servers are coming up with 16 GB RAM or 24 GB RAM. When you have 24 GB RAM and a 64-bit application server, if you give 1.5 times the size of your RAM for your swap file, then you need another 35 GB of hard disk space, which is actually a waste. According to experts, you know, a 64-bit application server or a 64-bit server should never swap. There should not be any need for a swap. A 64-bit server with 16 GB RAM should never swap. So there is absolutely no need for a swap file actually. If there is swapping, then there is some problem. Anyway, so that is a little old concept, 1.5 times. It's applicable, that's correct. It is used in the Windows world in 2000, 2003 and things like that. So that's how you should look at it. So don't take that word, okay, Gene, swapping the thing. So anyway, in a VMware world, every VM, that is the case of VMware, it's different. Every VM will create a swap file, unfortunately, equal to the size of the memory. It's not 1.5 times. If your VM is having 20 GB memory, it is going to create a 20 GB swap file. I don't know why, but that's how it is. There was already a lot of debates and discussions going on. VMware is aware of that, but I think there is something that is limiting them or stopping them not getting rid of that. It's a big problem. In our office, if I have 100 VMs with 20 GB RAM, you can imagine I need 2 terabyte of storage just to store my swap file, which is a waste actually. And how much my VM swap? Very little. So that's a different story. But anyway, in VMware, you know what a swap file is. Every VM has a swap file, and that file is called as a VWSP file. Where is that file actually? When you create a VM, where is that swap file stored? You cannot delete a swap file. If you don't have a swap file, VM won't start actually. In the data center, Satya is saying in the data center. Data center? or data store you guys meaning? See, that's a big difference here, okay? If you are trying to say data store and data center, they are two different things, okay? Very, very careful. These are the things you need to practice. If you go and say data center, it's a different thing. Yeah, DS is a much more intelligent way. I don't know what is DS though. Right, Arvind? So be careful on that. It's not data store actually. The answer is not correct actually. It is actually like VM. It's in the VM's working directory. That is where it is stored. That's the right answer. It is stored in the VM's working directory inside the data store. A swap file will be created. Do you know when a swap file is created for the first time? I mean, I told you all this, I showed you all this. Yeah, when you power on a VM. If you create a VM, you're not going to see a swap file. A swap file is created when you first time power on the VM. That is the only time. If the rebooted is not correct. Rebooting is nothing to do with it. Power on and power off. That is when a swap file is created. If you reboot, nothing happens to the swap file. It will stay there. So, anyway, we discussed a whole different topic, but here. So when you create a VM, there is actually, by default, VMware recommends to store the swap file in the virtual machine, same directory as the virtual machine. It is written here, store the swap file in the same directory as the virtual machine. So it is the recommended thing, but you can actually specify a different location if you want, a common location. This is something that is done in very high performance environments, where you can point your swap file only to a SSD storage or something. You know that nowadays there are a lot of flash memories and all coming up. So if you have flash memory storage, you can point your swap file to a flash memory rather than a fiber channel storage or a ISKC storage, so that the swap file can perform faster because it's a flash memory. So there are options like that, but I don't recommend this thing. It can create a lot of problems with vMotioning and all. So that is what that is. This is not a very important thing, but I just wanted to mention that. Okay, so you can store, if you set this thing, you will get an option when you create a VM. You will get an option to keep the swap file outside of the virtual machines directory. But VMware strongly recommend you to keep it on the same directory. So that is it. The cluster is done. Cluster name. This one VMware EVC mode is disabled. And the swap file thing, we said, okay, store it in the same directory. Click finish. And you are creating the cluster. You can see that the new cluster will be created here. See, this is the new cluster. If you look at this cluster, now the cluster has some property. You can see that the DRS technology is off. We will learn about DRS. HA is off. EVC mode is disabled. Total CPU capacity of this cluster is 0 gigahertz because there is no resources, no ESX server is there. Total storage is nothing, everything is 0 because there is nothing, we just created the cluster container only. So a cluster is actually the group of servers and the total power of that. That is what it is. There is no virtual machines in this cluster, there is no ESX servers in this cluster, so there is nothing in this cluster. If you want to see the properties of a cluster, right click on the cluster and go to edit settings. You will get back to the same thing. This is how you modify the cluster. I haven't turned on these features. When I turn on the features, we will see what is HA and all. I'm not going to do that now. Now, I'm going to add ESX servers to these clusters. Okay, Sandosh question. You cannot add VMs to a cluster. You have to add ESX. A cluster is a group of ESX servers. It's not a VM. So VMs will come as part of it. So you can right click on a cluster and add host. You can add host directly to a cluster like you add host to a data center. Add host, it's the same thing. You can do that. Or you can just drag and drop it. Click on this and just drag and drop it into that cluster. Now you can see that 91 is moved to the cluster. I'm moving 96 to the cluster. I'm moving only the servers that can be vMotioned. Okay, I'm just keeping 95 out of this cluster for now. Why I'm keeping 95 out of the cluster? Because 95 is a separate model. You know that it is a separate model. We can possibly use EVC mode and see. I don't know, because I think it is not possible, because these processors are not supported by EVC mode. Anyway, let us see. So now I have a cluster. Let us keep this server outside. This is not in the cluster. Okay. Inside the cluster, I have 3 servers, and look at my cluster's power now. My cluster, I'm saying I have 24 gigahertz of processing power. I have a total of 27.51 GB memory and almost a terabyte of storage for this cluster. How many ESX servers? 3 ESX servers. Total 10 processors. That is the total count of processors. Total number of data stores. Total 8 data stores are there. You can see all of them here. And total there are 32 virtual machines here. If you click on the virtual machines tab here, you can see all the virtual machines here now and the templates. If you click on the host tab, you can see all the hosts and their current status. You can see that the memory on this is kind of more, because now the server is having more servers maybe. And this is the percentage of utilization and things like that. This is showing more, but this has less memory. You see that it only has 4 GB memory, but this one is having 16 GB memory, and the other one is having 8 GB memory. I mean, that's in my lab it is like that, but in real world environment it will be much more. And again, one more thing, guys, these memories are very small for an ESX server, because I don't need much memory. In my office and all, average size of a memory is around 128 GB per ESX server. Some of our servers are having 256 GB RAM. We don't have any servers more than 256 GB RAM in our environments. I know some of my friends who work, they have servers with 1 terabyte memory. We don't put more than 256 because we wanted to limit the number of VMs running on a server. If I can put 512, I can put 50 VMs on a server. If I have only 256 GB RAM, probably I can put only 25 VMs there. So you may be asking, why are you not putting 50 and run more? The problem is, what happens if that server crashes or something goes wrong? Let's say the motherboard failed. What happens to those 50 VMs? Let us say somebody powered off that server all of a sudden, just went and unplugged the cable. What happens to that 50 VMs? Can anybody tell me? I have a server, ESX server, running 50 VMs. Okay, Santosh is saying it's down. Raiden is saying migrate, it's a question mark. Okay, good. But you shared in your first class, what? That there will be duplicate power source. Yeah, I'm not talking about power source. I'm talking about somebody went and purposefully unplugged the cable. Or I'm talking about a motherboard failed. Or a power surge or something happened. Anyway, server went off. That's it. Whether it is dual power or not, that's a different thing. So all the VMs will die. That is the answer. All the VMs will be. It is just like you powering off a VM. What happened? That is, if the ESX server goes down, every VM will go down. There is no chance for that VMs to migrate. Yeah, you could have done vMotion and all if you had enough time. Can you do vMotion in a millisecond? No, vMotion takes some time, like 5 seconds or 10 seconds or maybe a minute or maybe 5 minutes, depending on the size of the VM, depending on the load on the VM. vMotion needs some time. It has to transfer the memory, then go back and copy and all. But when you power off a VM, ESX server in 1 second, there is no time to do vMotion and all. There is no time to migrate. There is nothing to do anything. All the VMs will die. Correct? Can this actually happen in real environment? Sure, yeah, it has happened in our environments many times. Many times it has happened where a ESX server has, well, that is why VMware has this clustering technology, And that is where this technology called HA is going to kick in. I'm going to explain that now. HA is for that purpose. vSphere HA detects failures and provides rapid recovery for virtual machines running within a cluster. So that is what we're going to look into it. So clustering, that is the importance of clustering. So I think I'm missing something. I wanted to tell something. I think I don't know where I started the discussion. So so clustering is meant for that.
Deepak,
yes.
I know you didn't select those two features. Just bare minimum cluster you did. What are we going to get in this type of scenario? Benefit of the cluster, just the base cluster.
In this scenario, basically you are not going to get any features. Actually speaking, you are not getting really any good. And actually speaking, you are not getting any real features of the VMware cluster. It is just you can organize everything together. You can see that all the VMs in one window. You can see something generally, but other than that, you can see all the storage together and things like that. But other than that, you are not getting any real benefit. It's just like the VMs running earlier. Yeah, there is no. This is now we created a cluster group and added. We haven't started. That's what.
Basically, this is just grouping the hosts.
That's it. What I did now is just grouping the hosts together, and you can manage them as a single entity. So the cluster has features. Those two features we haven't turned on yet. We're going to turn them on, and we're going to understand that. So these are the two major features in cluster. But you can, without one feature, since you asked that question, let us say these are different. This is running Meron, this is running Penryn, and this is running Nehalem. I can now apply EVC mode to this cluster, and I can do manual vMotions. I can vMotion between the servers in that case, because I have a cluster, and the cluster is having an EVC mode setup at this level. Now that I have this setting, it's not possible because it's you can see that it is different AMD. So let me do this. So you can see AMD processor. So now I have done that. So this is a question, what you asked. So now I can, even though my servers are running different processors, I can vMotion them, and that is a cluster feature. So since you asked that question, Sri, I never thought about it, but that is it. Okay. Without a cluster, you cannot apply EVC mode. Correct. Is that correct? Any question? Okay, so that is the advantage, but it's not just grouping, though I said that, but now I was thinking, actually it's not correct. You created a cluster, you have a cluster feature actually called as EVC mode, which is actually turned on. So because of that, you can vMotion between the VMs if they were all different processes. But in our case, you don't need EVC mode because all our processors in this cluster right now, 91, 96, and 97 are same processor family, so we don't need EVC mode. In this case, it is pretty much as you said, there is no need to do it. So this is what a cluster is. So this is what, so you understand a clustering is nothing but a group of servers together. You can get some benefits, but we're going to look into the properties of cluster, and I wanted to finish the HA thing. So guys, why don't we do one thing? Let us take, it's 9:42 now. Let's take a quick 5 minutes break or a 10 minutes break. You want 5 minutes or 10 minutes? I think 5 minutes will be good, right? Okay, let's take a 5 minutes break and come back. Okay, so I'm going to talk about this HA feature. It's 10 o'clock probably. Hopefully I can finish it. Let's see. Okay, I'm going to draw an environment here. Okay, so this is a completely clustered environment. There are 4 ESX servers in this cluster. There are 3 LUNs that are shared across this cluster. And there are 6 VMs that are running in this cluster at that current setting now. 2 of them are running on the first one, 2 are on the second one, and then 2 VMs are running on the last 2. And color combinations are given so that you know which VM is running on which LUN, things like that. So this is a completely fully configured cluster. You know, this is a complete cluster. Any doubts or any questions anybody has on this picture? Did you understand this picture completely? Okay. So this is the current situation. Let us say all the VMs are running, everything is fine, day is good. Also remember, you know, the ESX servers, I'm not talking about the VM networks or anything. I'm talking about the only the management interface of these servers. So let us put a switch here. This may not be the correct condition here. There are, you know, these are switches. This is a physical Cisco switch. Let us assume that. And let us also assume that, you know, each of these ESX servers are connected to this switch. For management interface. So these are the network cards that are using for the management interface. So that are VM kernel port groups. These are ESXi servers. Management interface is connected, so these servers are connected. So this is the current situation. So when you have HA, HA stands for high availability. So let us go here and enable the HA feature of this. So I'm going to say HA enable on this thing. You can see that when you come to HA, you can see that there are some functionality, then there are some options, then there are some VM monitoring options, data store heartbeating. There's a whole lot of things we got to go through. HA is not that simple. There's a lot of things you need to understand. It is very simple and very interesting, but there is a lot of things to talk and cover. So I'm going to enable, or I enabling HA feature. The HA feature in VMware has been redesigned recently, probably with ESXi 5 onwards. They redesigned HA. HA was there from long back. I think it was there from ESX Server 3.0 onwards. HA was there. It was pretty much the same thing. Nothing much has changed. Some features are changed. So in old days, not old days, I would say, you know, earlier version of HA actually uses or used a service called AAM service, Automatic Availability Manager Service, which is actually a service from the old Legato infrastructure. If you know the Legato backup software and all, you know that it was a service that was borrowed from Legato, which was called as AAM service. It was using that service to run the HA feature, but that is gone if you are not using ESX 4 or 4. If you are using ESX 4 or 4.1, you are still using the Legato's technology called AAM service. But now it is not there. VMware has completely get rid of that, and VMware has came up with a new technology called as FDM service, called as Fault Domain Manager service. Fault Domain Manager is a small daemon. It's a small service that runs on every ESX server. It actually, when you enable HA, the HA feature, the Vcenter will install. Vcenter is required for clustering, right? Vcenter is required for HA configuration. So when you configure HA or when you enable HA in your cluster, it will automatically go and install a service called as FDM, Fault Domain Manager Service, in every ESX server. In the past, instead of FDM, it used to install the service called as AAM service. AAM is having some challenges. There was some failures in the back. Sometimes you can see that HA gets failed and things like that. It was difficult sometimes for HA communications. If the DNS is not configured properly, HA was not working. There were a lot of challenges, but that is all been over. It's all been undertaken now. The new FDM feature is very powerful, very stable, very strong. It has been in the market for almost 2.5 to 3 years now. From ESX 5 onwards, FDM service is what is. So we are going to focus on FDM. I can give you some links if you really want to understand what is AAM services, but it's pretty much safe. So when you install VMware HA feature, or when you turn on HA feature, what it does is it goes and install the FDM service on every ESX servers. And then the FDM service on every host communicates to each other host, the FDM service on another host, every 1 second. And that is called as a heartbeat. So the ESX servers communicates or do their heartbeat by using the FDM service with the help of the management interface, which is nothing but a VM kernel port. So it uses the management interface to do that communication. So every server in your cluster will get this FDM service, and then once the FDM service is installed and configured, they will communicate each other. So when you have the FDM service installed, they will act as a domain, or they will act as a group of servers. In that group of servers, there is always one master, and the rest all are clients. It's a master-slave concept. All the slaves will report their health, their status, and their whereabouts or whatever to the master always. And the master keeps a major the main database. It updates the database. But master also updates every other slave about the changes that are happening in the cluster. So the heartbeat communication does that. In the past, when it was FDM service, it was little different. There was something like a master and secondary. So it was not master and secondary. It was called as primary and secondary. There were one primary server and 5 secondary servers. And the remaining servers are not considered as primary or masters. They will stay. So in a cluster, in old days, you can have 1 master and 5 secondary servers, and then the remaining all can stay there. I forgot to mention one thing. In VMware ESX cluster, you can have up to a maximum of 32 servers. The biggest cluster you can make is 32. You cannot add more than 32 ESX servers to a cluster. A cluster can have a minimum of 2 servers. You can create a cluster with 1 server, but that is not a cluster, right? So you can create 2, at least you have to have, but to a maximum of 32 nodes. So with the new FDM service, or with the new HA technology, you will have 1 master and 31 slaves. Aravind is asking question, who is the master? Typically, the master is being elected, so there is a lot of algorithms, there is a lot of technology going behind this technology. It typically calculates or finds the master using many scenarios. I don't know the exact details of it, but some of the things are, it look at who is the most powerful server in the cluster. Sometimes it will pick the first server as the master. more, I mean, in a cluster, typically you know that typically in a cluster, the first server will become the master, because in a good designed cluster, every server should be same. That's what I prefer. I will recommend that. You should not be putting a different combinations and all. That will actually create management headache. So I always try to keep every server in a cluster same configuration and all. So typically the first server which gets the AAM or the FDM service will become the master, but that is not the actual criteria. The actual criteria is based on who is the most powerful server. He will be the master. It's not only the powerful feature, which server is having maximum number of LUNs. That's a good feature. That's a main feature it normally looks for. If one server in the cluster is having 10 LUNs attached to it and all other servers are having only 7 LUNs, the one with the 10 LUNs will get the master role. Large companies, I have a couple of my students, my earlier students, three of them are working in AT&T. They are working on large clusters. They are working on completely cloud projects now. I've been in touch with them. Actually, Gene, your friend Pramod, is working in AT&T, Verizon, right? Not in AT&T, he's in Verizon. All their clusters are 32 nodes. That is a huge data center. They are actually a cloud provider like Amazon. For them, every server is okay. So there, every cluster is 32 nodes. But if you come to my company, we have our biggest clusters are 16 nodes. We don't have 32 node clusters. There are some other reasons why we don't manage or we don't want to build 32 node. We could always do that, but we have certain other business reasons why we don't want to make that. It is probably, I will talk about that later when we get onto some LUNs. If you have more LUNs and all to a cluster, it could create some problems and all if you have large servers. When you talk about data centers that is doing a cloud solution, most of the VMs are typically small VMs, but when it comes to a financial company or something where you're running large VMs, keeping a 32 node cluster could be a problem. So we don't know, but I think some best practices is to keep a little smaller. So I have talked to many people. One of my students is working in Johnson & Johnson. He said, their typical cluster size is 10 nodes. We have clusters with 16 nodes. We have clusters with 10 nodes. We have clusters with 6 nodes. We have clusters with 3 nodes. The smallest cluster in our company is 3-node cluster. We have a couple of 3-node clusters also. And those are small applications. I will talk about these clusters probably in my last class where I explain some real-life scenarios. I try to keep one class to discuss about some real-life environment so that you can perform in interviews and all. At that point, we'll discuss that. Anyway, the cluster can have up to 32 nodes if you want. So that's how the FDM thing is working. FDM, FDM is the Fault Domain Manager Service. So I'm going to say OK here. And you can see that as soon as I say OK, you can see that it is happening here, reconfiguring cluster. You can also see that it is installing or configuring HA in every node. You can see that it is basically installing the FDM service right now on the cluster. Every node is getting that FDM service. You can see that it is installing that. It takes a while because it has to install that daemon. It is doing that service now. You can see that when it comes, there are already some issues and all is showing, insufficient resources to HA failover node. These are all typical problems. We will have to troubleshoot now. Let me see this. What is the problem here? Okay, I think that's okay. That's fine. We'll talk about that later. Okay, so now you can see that the HA is configured, the AAM service, FDM service. If you go to the 91 and go to the configuration and you go to the security profile, you could see the network load balancing, VMware high availability agent. This is that FDM agent. You can see that now the vSphere high availability agent service is installed and it is configured and all, or it is working. When you take a server out of the cluster, it will automatically uninstall this. If you uncheck, if you remove or disable HA, if you disable that HA feature, it is going to uninstall. As soon as you uncheck this, it is going to uninstall that feature from all the servers. Okay. So that is the thing. So now every server is having the HA. You cannot find out who is the master and all from here. It is there are some other command lines you can use to find out, but at this point that is way outside the scope. I'm not going to get into it, but that is how it is working. We'll look into that later. So this is how it is. Every server. Let us just for understanding purpose. Let me just try to put a small block here on every server. Just for the understanding purpose, okay? Let us say that is the FDM service. Every host is running FDM service. And now these FDM service, so let us say one of the server in our cluster is the master. Let us say this is the master server. Let us say that is the master server, the one in green, or let us make that is the red server. So this is the master server, and the others are slaves. And all these servers communicate using this management interface. That's how the heartbeats are. So every server know that, or the master know that every server is running. If one server is not sending heartbeat, it immediately know that that server is having some problem. Correct? So that is what it is. So every host in this network, they know each other about others' presence. How do they know? By using the FDM service, the heartbeat messages, they know that. Okay. So this is the condition. Now the FDM is increased and everything. So now I'm going to talk about another incident now. Let's talk about, now I'm going to take the pen. Let me take the pen. Let us say this particular host goes down. For some reason, it went off, the power off, somebody powered off this server or something wrong. I mean, we don't need to tell, it went off, that's it. I don't know. What happens to this VM? that VM will also die, correct? It's not crashing. This VM actually, yeah, it crashes. This VM will die. As soon as this goes down, the master and the other nodes in the cluster know that this server goes down because they are not getting any more heartbeat messages. It will wait for some, probably for a couple of seconds or something. Is there a heartbeat message coming? If it does not see a heartbeat message, they will declare that that particular server is down. They know that this particular server is down. Now, the HA feature will start its job. What HA does is, HA know that this VM was on that server, so HA know that this VM is now down. What HA does is, HA does is based on what we are telling HA. HA can power on that VM HA actually can power on this VM on one of the other hosts, any one of the hosts. HA look at some load factors, which server is having least amount of load. Now there is only 3 nodes because you lost one node. The cluster is now in a bigger problem because the cluster lost one node. HA will restart that server, restarting that VM, meaning it registers that VM to a new host and power on that VM. But definitely there is a power outage, there is a disaster, but the good part of HA is HA will be able to bring back that VM in a very short period of time. So a lot of people think that HA, in Microsoft world or any other world, HA means high availability, means there is no service interruption and all. That is not correct in the case of VMware HA. VMware HA means not that, even though it is called as high availability, I don't know why they call it as high availability. In this case, I was telling Redden the host goes down, so the VM also goes down. That is what I am saying. If a VM just goes down, HA is not going to do anything. If the host goes down, and which in turn brings the VMs down, this is what happens. So, in this particular case, the host goes down, the host is now down, no heartbeat, and HA will bring up that server here. So there is definitely a service interruption to the business, because their business, this was their Exchange server, or maybe this is the PeopleSoft HR server. The server got rebooted. Definitely there was some problem. But the good part is, in a small period of time, it was able to restart by itself automatically. If you don't have HA, and if the server goes down, you need a VMware administrator to go and identify that VM, and then you have to manually start that VM and all. It is a long process. So let us say in the middle of the night, if one of the ESX server goes down, when it goes down, it went down with another 20 VMs. In a big environment, definitely there will be at least 15 to 20 VMs there. We are talking about 15 VMs powered off now because one of the hosts dies. I don't know, I'm sleeping at the night, but this is what happens. If I have HA configured properly, do I have to really worry that much? I mean, there is definitely a reason to worry because all your application servers in the middle of the night got rebooted. They might be used by offshore people, that might be used by people in Australia, I don't know. But anyway, I don't have to do much things now. I can look into it tomorrow morning. I have enough resources on my remaining cluster host. My VMs got restarted in 5 minutes and everything back to normal. That is what HA does. Any questions, anybody at this point? Okay, no answers, so that's fine. So moving on. What is Arvind's question? So typically the cluster keeps the host of the distributed, I don't know what is DCs means. Typically the cluster keeps the host of the distributed DCs. I don't understand what your question is, data center. Okay. Cluster keeps the host of the, I don't know what you mean by that. A cluster, we are talking about that group of servers. In a data center, you can have many clusters. We are talking about one cluster in the data center. And if a whole data center is down, there is no question about a whole data center is down. We are talking about clusters. So I don't know. There is no reason for a data center to. The data center is a logical grouping. It's a logical thing. There is nothing actually a data center can do. There is no properties for a data center or anything. Data center is a root management piece. It's a logical concept. There is nothing for a data center, but a cluster is not like that. You're speaking about a physical data center. Okay, I don't know what you mean by that physical data center. See, you're going way above that, speaking about physical data center going down, like a 9/11 attack. You're talking about the whole office goes down. All the servers will die, all the people will die, that's it. Power outage, yeah, everything is down, that's it, nothing can be done. What can you do? I mean, then there are disaster recovery things, replication and all, but that is not I'm planning to teach here. Okay, there are many things that can talk. There are companies who have money, has many technologies to come out of that kind of a scenario, but that is nothing here, and that is not we are talking here. So I don't think you should not go that far here. Let us talk and keep our focus on this cluster technique now. But you're talking about a technology about way outside of the scope of this class. I mean, that's way outside. If a data center goes down or the whole office goes down, what you do is a different thing. Okay. There are techniques and there are companies do that, and that is how companies will do their BCP plans or disaster recovery plans and all. But that is not part of this thing. What I'm talking is about a cluster and the thing. So we are talking about one host going down inside a cluster in a cluster. Not that's all. So this is what H does. Okay. Now, there is another scenario that can happen. Have you anybody heard about a situation called a split brain condition? Have you heard about split brain condition? What is split brain means? Yeah, I will talk about that in a minute. Okay, so that's I'm bringing back everything is like this. So you understand what that HA means. If a host goes down, what ESX server can do that? You know, the FDM service will restart the VMs so that the VMs will come back on and everything is good. But HA has some problems too. HA can create problems. Let us say for some reason in your cluster something went wrong with this cable or that switch port or that interface or maybe this network card. Something, maybe the switch port goes down, maybe the cable got cut, or maybe the network card failed. What happens to this VM? What happens to that purple VM? That is my question. This VM, what happens if this goes down? Actually, I'm waiting 5 minutes for your answers, guys. I think you should open your mic and speak now. Okay, I think that will be better because I need a lot of interaction to go with this. Otherwise, I can take a different route. Nothing happens to that VM. The VM will be fine. That VM will continue to work. The VM will be up and running. The business is running. Do you think any problem there? It would restart. So I'm seeing many answers here. That is why it is called a split brain condition. That's why I'm trying to put this scenario here. I mean, there's no need for to explain, but I'm trying to explain in a real life scenarios. HA's problems. I only have lost this management interface, guys. I told you this is a VM kernel port. You think that ESX server will only have one network card? ESX servers will have many other network cards for its VMs to communicate. The VM is communicating through this network card. The VM is running. The ESX server is running. The storage is available. So what is wrong in this VM? Nothing is wrong. The VM is very good. People are accessing the VM. They are all doing everything on the VM. Only thing is that you cannot connect to the ESX server. Or you cannot talk to the ESX server. But the VM is running. The server is running. The VM is talking through another network, isn't it? Look at this picture here for a minute. This server, this is not a good example. Let me take the server. This server is managed by using this network card, isn't it? If this network card goes down, okay, these VMs will have problem because these VMs are communicating through here. But do you think there will be any problem with these VMs? Or these two VMs, Raiden's two VMs? They are communicating through this network. The ESX server is up and running. The problem is with this NIC down. So there is absolutely no problem for these VMs. They are using totally different switch. They are using separate network card. Everything. The ESX server is running. The only problem is the network card. Okay? And that is what that is happening. So, that is all fine. But the problem is now this is down. What do this master think now? And what do these hosts think? What do they think? They think that this guy is down. Not the VM is down. They think this host is down. Because they are trying to talk to the host. They are not talking to the VMs. Isn't it? Now, if the host is down, what are they supposed to do? Come on, guys. Move the VM. That's not correct. Failover port group should open. I don't know. Aravind, you are just simply going way ahead. Okay, I think the way you are thinking is not correct. Okay, that should not be the way. Think very low level. Things are very take it very simple. I don't know what you're talking. Also, you're talking about failover port group should be open up or something. I don't know what that means. That's all your way of referring things. What happens is HA will restart this VM because that is what HA is being told. So this VM, HA will restart now because this VM is currently running, but HA does not know that. HA will forcibly restart this VM and bring that VM to another host. Maybe to here, maybe to here. I don't know. Let us say it is here. It restarts the VM here. That is what HA is supposed to do, correct? If the host goes down, HA will understand what that VM is. So it is not moving, Santosh. it is restarting the VM. HA cannot do any vMotion or anything because the management network is down, the VM kernel is down, the VM kernel port group is down, no way to do vMotion or anything. And HA does not know what is vMotion is. HA does not know what migration. All HA knows is that restart the VM on another host. That means what HA has done now is HA has restarted one of my Exchange server or my most critical server without a reason. The VM was running, people were accessing it, everything was good, but just for the heck of some network guy's stupid mistake or some problem with a network card, HA is going to restart that. Is that a good thing? So that is not a good thing. So that if that kind of thing can happen, so that is called as a a split brain condition. That means just by having the VM getting disconnected, the VM was actually running. Now HA forcibly restarting that VM is definitely intolerable. I cannot take that. My host was fine. My VM was good. The only thing is that just because you are not getting heartbeat, it's a TCP IP communication. Just for the fact that you are not getting some 10 heartbeats, you're going to restart my critical Exchange server? No way. That is a different bad thing, right? So that should not happen. So how do you deal with this? It can happen, right? So that is one of the issues. I'm just saying, can we have a NIC teaming with failover? Yeah, I mean, NIC teaming failover, both NICs fails. So just don't try to contrast to me. You understand the concept. I know you can question back with me, or I can have another VM kernel port group. That's all different story. Okay, can we have a NIC team with failover? Yeah, sure, you can. Then there is no problem. Fine. But if both NICs fails, what happens? What happens if whether you have two NIC cards? Fine. What happens if the switch fails? Now your teaming has nothing to do there, right? Your teaming and all, but your switch fails means you are gone, right? So we can put different scenarios like that. So I'm just telling. So try to understand what I'm trying to tell you here. Okay. So this is the scenario. This is what happens. So that is not the correct thing to do. That restarting is not an option. So we should address that issue. Is that clear? Okay, now another condition. We will go back and show. I will show you all these, but I just wanted to explain with this picture or how these things really happen. Guys, believe me, no class, no teacher will show you like this picture and all these things. Okay, this is like I'm going in, like this is all you can get. These kind of scenarios is probably in going for a VMworld session. Probably you can see somebody, and that too he has a 1 hour time. He has to talk the whole clustering. But try to understand that. So don't go beyond that what I'm teaching. There are many things you can think and you can consider in your mind and all, but that's not the thing. Just understand what I'm talking and think in that perspective. So now I'm going to talk about a new scenario. So I talked about two, now I'm going to talk about another scenario. Let us say these 3-4 hosts are there and they are all running at high level. Let us say this server is like 90% CPU and memory utilization, because these two VMs are taking all the memory and CPU 90%. This is also like 95%. Okay, it's going, but you have to understand that is 90%. I cannot write it here, that's why. This is at 95%. Yeah, there is only one host, one VM there, but it is 95%, because this is a heavy user VM maybe. Who knows? This may be an Exchange server. This may be a SQL server. This is also running at like 85%. This may be a SQL server. This is your Exchange server. These two are some application server. This host is also very busy. All the hosts are above 90%. Okay, I'm talking about a scenario here. Now, also imagine a case. These are all different scenarios. Okay, these are all things you will realize when you get into real life thing. I'm just talking from my real life experience. These things, guys. Let us say this is the case, and let us also think that these two are our UAT servers. But the ESX servers is running 95%. These are heavy hitting boxes. But they are these two are UAT servers, and all these are production servers. Means these are the business production servers. These are the UAT servers. So from a business perspective, these four are the critical servers or the VMs. I'm talking about VMs now. But all the servers are down. I mean, all the servers are up and running. Now, you understand these are UAT servers and these are all production servers. Now this server goes down. What happens? Tell me, guys, what happens if that server goes down? Okay, HA will kick in. HA will restart that red and blue VMs in another host. Correct? That's correct. It will do that because the host goes down. Let us assume that HA restart this server here and probably this VM on this host. Correct? Are you all with me on the same page? Do you think that will happen? It will happen, correct? Which is fine. This happens, everything is good. But now, what is wrong here is the CPU and memory utilization of this server will be like 125%. I mean, there is no such percentage. That means this server is now in high pressure. This server is in high pressure because you added two more VMs here. They are taking all the CPUs and all. Now what exactly happens is this will affect your production server's performance. Isn't it? Now your production servers are not getting their required memory. Your production servers are not getting their required CPU power. They become slow. The business start complaining. Your entire office will go slow. It becomes a big nightmare and you have calls and things like that. What is happened here? Two UAT servers came there and it is taking all the power. I'm giving you an example of a UAT server. It could be a development server. It could be maybe a low priority production server. But whatever happens because of a critical situation like this is what happens. Are you okay with this? As a real VMware administrator, do you tolerate this? You don't. So what do? How do you address this issue? HA don't know that. HA is doing his job. So that is another problem. So there is workarounds to do that. We will look into. So you understand this is another problem. I mean, creating a dev cluster is not an answer, that's fine, but it could be a low priority production server also. So it is very important to plan your cluster. So typically in my office and all, we always plan the cluster in such a way that it is in an N+1 configuration. N+1 means we always keep one host worth of resources free. It doesn't mean that the whole one host is always kept as a standby host. If one host fails, every load can go to that server. There is an option to do that. That is a bad thing because an HA incident can happen probably once in 2 years. In my entire VMware life, I've been working with VMware for past 10+ years, guys. I have seen HA incident happen only like 4 or 5 times. But I have seen, okay, real HA happening in my environments. But it has happened only 4 or 5 times. Just for that purpose, do you think that is it a good idea to keep an additional host just for HA? I don't think that's a good thing. So you keep everything in a cluster, make everything as part of the cluster, let them all have VMs, but always make sure that your cluster will have some space, some resources available to take the failure of one host. Meaning, if one host fails, and if 10 VMs are coming up on other 9 hosts, let's say you have a 10 node cluster, if one host fails, then your remaining 9 hosts should have that resources to support that failed VMs without affecting the performance of other hosts. You getting what I'm saying? So that should be the way you should design your clusters. If you don't consider that, if it is okay to have a performance degradation on all the VMs like what we are seeing now, then it is okay. But in a real world, in real good, well planned, well designed cluster, that should not be the way. You should plan that failure and all. So you can have one cluster failure, one node failure. You can have an n+2 failure, things like that, depending on the criticality of the VMs, depending on what type of servers you are running. You may want to design a one node failure, 2 node failures, things like that. You can design your cluster that. Make sense? Okay. So that is some of the things about clustering. Okay, HA clustering. So this is one of the feature of HA, and that is what HA is. Now let us go to the HA properties. So HA is enabled in this cluster. Now you know what it is. So I'm going here, and first thing is enable host monitoring. You have to have this particular thing checked, then only the heartbeats will start working. If you don't have that, they don't do. So they are saying if you are doing any network maintenance, if you are doing any network card maintenance or something, uncheck, then it will not do that split brain situation. Otherwise, what happens if the network guy is doing some work, what the host will think? They think that other hosts are down and they will all get mad and they do try to restart everything. So be very careful with that. But in a typical well-planned environments, you will not have problems because no networking guy wants to take a switch down like that, right? If a switch goes down, they will always have redundancies and all. But if you're really doing some network maintenances or you're working on your network card or your uplink, it may be a good idea to disable that. But that's just a new feature they added here. Admission control. That's another feature of HA. Read this carefully. The VMware vSphere HA admission control policy, it's are all policies, determines the amount of cluster capacity that is reserved for VM failovers. So the admission control determines whether the remaining host, let's say you have a 4-node cluster and one host fails, the admission control decides whether the remaining hosts are having that capacity to take that failed VMs. So reserving more failover capacity allows more failures to be tolerated but reduces the number of VMs that can run. You can always have more failover capacity, but then you reserve that much, then what happens is you can only build small VMs. So by default, the setting is enabled. That means disallow VM power on operation that violates availability constraints. It's easy to understand. Let me try to explain it to you. What that means is, so if you have this thing enabled like this, and if you have a condition like this happens, the admission control policy know that, oh, you know, these three guys do not have the capacity to bring up these hosts. this host failed, but now the admission control know that there is not enough capacity. Why? Because these are all running at 95%, correct? If this is the setting, it will not restart the VMs. It will say, okay, you are down, because I don't have the capacity. So you will not affect the performance of the other VMs. But there is a problem with that. You have to remember. Let us say instead of this host, if this host is down, now your most critical production servers are down. But HA will not power them on because you are again violating the available. But that is a thing. So that is all you have to consider when you're designing a cluster. I don't know how to explain that, but these are all things. So you should plan what VM should be in a cluster, how they should be put, and also it's not just under creating a cluster. You have to plan many other things if you really want to design a good cluster. So I'm just saying that when I said this scenario, it was understandable. Oh, UAT servers, no problem, let them be down. But if the other thing happens, if this host goes down, it's a different scenario, correct? So that's another thing. There is another code. You can disable the admission control. When you disable it, you see that all these things goes off. Allow VM power on operation that violates constraint. If you do that thing, then it doesn't care whether there is power or not. If the one host goes down, it will restart them on other host, no matter what, whether it is performance problem is there or performance or not. HA does not care about that. HA will restart. This is what disable means. You're getting what that, right? So that is what that setting means. Now here is where the admission control policy of the HA, where you can say how many host failures you can tolerate. If I have a 4 node cluster, I have enough small, let us say I have 20% resources reserved here, 20% here, 20% here, 20% here. I can probably say, you know what, I can go up to a host failure of 1. And what is that? Virtualization arc is better than admin if you already know other areas and high level HA understanding and you're talking about me? Okay. Or earlier question about going too fast. Okay, let's leave it. Let's finish it. That's the thing, guys. Okay. So this is the thing. Host failures. Yeah, Satya, I will try to stop it, man. I also have to get up morning, but I cannot stop this at this point. So please hold on. Okay, I will try to finish it fast. So here you can determine how many host failures you can tolerate in a cluster. You can specify that. You can do it that way, or you can say, okay, reserve certain amount of CPU and memory. You can do it that way. Typically, in my office and all, we always go with host failures. Or the last option I said, you can always specify a host. You can click on this and say, okay, 97 is my failover host. That means if something goes wrong, move everything to 97. But I don't think that's a good idea to do that. So you can leave it that way also. So I don't think that's a good option. But in some scenarios, maybe you want the failed VMs to be started on a particular host. In that case, that host will be just sitting there waiting for HA. You're talking about a ESX server, means you're talking about a $40,000, $50,000 worth server doing nothing, probably for 3-4 years, maybe for the entire life cycle, without having anything, because you are waiting for HA to happen, because that is dedicated for that. So I don't think this is a good option. Maybe in some companies do that. So mostly this is the best option. So host failure cluster one, this is the best option to do that. Or you can do that if you are doing more math and you are doing better calculations and all, you are really monitoring your environment, you pay so much attention on how much utilization is happening and all, you could do this also. But I think doing that is the best option. Now these are the general options of HA. Now coming to the second option here, virtual machine options is there. So this is better. Now you will understand a little bit more better here. So you have a couple of settings called cluster settings and virtual machine settings. So the cluster setting is basically this is one of the things in a host isolation. This is talking about the split brain condition I was mentioning to you earlier. Split brain condition, where is that? Okay. What is split brain condition? What happens if this NIC goes down, correct? So I was asking, how do you tell the HA if a split brain happens, what it should do? Does it restart or it should not restart or whatever? That is what that setting is. Host isolation. Host isolation is called as the split brain condition. If a host isolation happens, you want to leave the machine powered on. If you want it, you can say power off or shut down. That is your choice. But by default, leave powered on is the option. And I would strongly recommend to leave it that level, because in a network there could be, I have seen more often than a host failure that there are split brain conditions are happening, or maybe host isolations are happening. So that is this particular setting. And the VM restart priority, you can restart in a high priority, or you can do, so let's say you don't want a VM to be restarted. For example, the other is, and this is the cluster. This host goes down, and you don't want these two UAT servers to be started. But if this host goes down, you want these to be started. How do you do that? That is how it is. You can pick your server. Don't do it the cluster level. It is medium. Everybody should be restarted medium. Means it will wait for some time and it will restart. If you want, you can make it to high priority. That means if the cluster, if the host goes down, in next second it will try to restart. If you put it medium, it will wait for probably for 1 minute or something. I don't know what the time, but it will wait for some time. It does not say it will restart. That's okay. That's a cluster setting. You want the restart to happen. But let us say 3002 is a UAT server. I don't care about that server. If that host where this VM sits goes down, you can say explicitly come to the VM setting here and say disable. You can go to 3005 and say disable. Now, if the host that runs these two VMs goes down, Vcenter will not, sorry, HA will not restart these VMs. You getting what I'm saying? That is what this setting means. Now you are explicitly teaching, you are teaching HA, hey, you know what, these are something I need to do. Don't restart these two VMs because they are my UAT servers. I don't care about them. If the host goes down and they go down, that's fine. When do you want to do all this? If you have resource crunches in your environment, if your cluster is running high tight. In my office, I don't have any explicit settings like this because we have enough resources. Even if one host goes down, I know my 15 hosts, remaining 15 can handle the load. If I have a condition where I don't have that capacity, that is where you need to do that. Especially when you have a mix of production and development servers in one cluster, you may want to do things like that to keep the performance of your production servers high. If you don't do that, nothing happens, everything will run, but probably it could hit the performance of your production servers. So that's how you do that. If you want a machine, so if let's say if isolation happens, if you want this server to be immediately shut down for something, you can do that also, or you can leave it a cluster setting, which is nothing but leave powered on. So that is what that setting is. Okay. Moving on to the next one, we are monitoring and data store heartbeat. So these are two more settings. I think I don't have the capacity to do that now. So let us stop here. Let us reach tomorrow's class. Tomorrow we will do this and then we will do DRS. I think that's all I can do tomorrow, but there is a lot of things to understand and do that here. So we will talk about these things tomorrow. Okay. So I'm stopping here, guys. Tomorrow there is class. I already sent you the meeting invite. Tomorrow is Friday. And I will let you know about the Sunday class. There will be definitely class this Sunday. I don't know how many class. I thought of finishing of the whole course by Sunday. That never happened. So probably somewhere in by 24th or something, I need to finish it off. I mean, I have to put a stop somewhere. So next classes, we have still a lot more important topics to cover. I mean, I cannot continue this class because, I think my policy is if I'm teaching something, I should try to, I can, I mean, I want to teach it correctly. That's why I'm doing this. If I can finish off this HA in half hour, but that doesn't make sense. These are very important things. So we will do the class probably a few more days. Definitely we will take a long hour on 20th. I try to do a 4-hour class on 20th. Probably in the night, maybe in the afternoon, I will let you know. Sorry, not 20th, the 21st Sunday, no class on Saturday. Then 22nd is the last debate day. I don't think we will have class. I want to watch the debate, Otherwise, if Aravind and Raiden is ready to vote, I can vote for Obama, then I can do a class there. What is that? If Aravind and Raiden say they can vote for Obama, I will teach on 22nd. Otherwise, I go to watch what others.
I said that's a good one.
I will never change Romney. I am sure Raiden, he will win. There is no doubt about it. And I can see that on the final debate, Romney will go panic and he will say more foolishness there. You wait and see. Anyway, so we will have class. I'll try to finish off the class probably by 24th or 25th. There may be some topics I might miss, but I will put definitely a final class on 25th days. So we'll do this tomorrow, these two things, and then we will go back to DRS. When you come to DRS, you see that DRS is even another big thing. There's a lot of things to go through DRS. Okay. When I say DRS, it's not just one thing. There's a lot of things to cover. So this is what a lot of features, this is how a cluster is managed. So there's a lot of things to cover there also. So we'll talk about it. Now one more thing. I know you all might be interested. I don't see much people doing any labs here though. But whatever whoever is doing, you can try here, but I would recommend you to create a new cluster and just move this one server into that cluster or maybe one more from this and play around with your settings, and then once you finish it, just move that host back to this cluster. Don't make any change to this cluster because this is something I want to teach and I don't want to screw up the things and make problems. So if you want, you can always create a new cluster within this. Sorry. You can create a new cluster within this New York data center. Call it any name. And you can add this host into that cluster and you can play around with your settings. Okay. If you want to add one more host from this cluster to here, you can do that. You can just drag and drop it. Now we have two hosts here. I'm moving it, but move host to cluster operation is not allowed in the current state. Okay, there is a problem because you have to take that server into a maintenance mode. I will talk about those things later. You cannot move once you have in the thing. So we'll talk about all these things later. But you have one host here outside, and do that. To put a server in maintenance mode. Can you create a cluster in a cluster? No, you cannot. You can try. This is a cluster. You cannot create a cluster here. You can try it out. So that's how it is. Try it out. So there is another cluster here. So play around with your settings here. Okay. See, now even that is not possible. Now, since I put this in the host, you have to put it in maintenance mode. When you want to put it in maintenance mode, all the VMs should be off. All the VMs should be powered off to put a server in maintenance mode. Maintenance mode is something we will talk about it later, but if you really want to do it, you have to power off all the VMs and then put it in maintenance mode and then move it out. Okay? Alright guys, good night. So we'll talk tomorrow later. Okay? Good night. Lab will be accessible only to the day of the class. When the class ends, the lab ends.